and welcome to homework number 6. So in this video we're going to look at operating systems, and we're going to look at 1960s computer system and how it worked. So a 1960s computer system would not have had an operating system. So how exactly did they work? Well, it's quite interesting. So the user would enter the room with a deck of punched cards, and this is what they look like. So as you can see here, they literally just have holes punched in them, not readable for a human at all. They would then switch on the computer, and these days I think we can both quite, safely say that we don't tend to switch computers on or off. Okay, so the computer at this stage would have been switched simply on or off. Then the punch cards will be placed into the reader of the machine. So as you can see, this is what a 1960s computer system may possibly have looked like. Here you can see this is the reader for the punch cards, but you can see there's no monitor, no mouse, no keyboard. Then the punch card will be placed in the tape reader. They will push a button simply to run the program. They would press the button to print the punch tape, and then simply switch off the computer. So computers then were simply quite mechanical, and what they would have done is solved very, very difficult equations, that kind of thing really. So things that humans can do, the computer will do it, but they would just do it much faster. And that's the purpose of a computer. So these days as well, computers do things that humans can do because humans make them, humans program them, but they do these things much quicker than we can. So what may take us days or weeks or hours, a computer will do in a few minutes. And then they will leave the room with the punch cards. Okay, so that's simply all a computer would have done in the 1960s. So think about what a computer does now and what you use a computer for. So the 1960s computer systems, as I said, were very different then. So the user would control the computer's hardware just by simply pressing a button to control the mechanisms. So as I said earlier, the computers back in the 60s were very, very mechanical. And the missing component simply was the operating system. Okay, so the operating system didn't exist. So an operating system is what made the computers very user-friendly. And it is the system software that controls the hardware. So obviously back in those days it was buttons that would push that they would push to actually program the computers and make them work. And the user would obviously control the computer system, but now we've got a system software that controls our hardware for us. So prior to this, buttons would control it at each aspect of the hardware. Okay, so now that's simply not the case. So what is a system software? So a system software is basically a set of programs that act together to allow the hardware and the application programs to work. So your application programs are the programs that you use, like maybe you use PowerPoint, Word, all sorts of things like that really. So all kinds of applications that we use. And the operating system is the foundation of the computer. Okay, so without the operating systems, okay, the application programs simply will not be there. Okay, so it's a bit like your house. Your house has foundations that it's built on. If you don't have the foundations of your house will fall down. So these operating systems were developed to become the foundation of our computer. Now, basically, the examples of system software doesn't just include the operating system, but it also includes utility programs. Okay, and hardware drivers. So your utility programs may be working in the background without you even thinking about it. Okay, so like for example, your antivirus software. Now, your antivirus software is working all the time to stop viruses coming into your computer system. And your hardware drivers, okay, is the software that simply allows our hardware to work. So, do we have to open up a hardware driver to use our mouse? Well, no, we don't. As soon as we turn our computer on and we access the system, the mouse works without us even thinking about it. But all these things are working in the background without you even noticing it, without you even realizing it. So, like, for example, if I want to use PowerPoint, I have to open up the application. But to use my mouse, I don't, okay, because it works in the background. So here's some examples. So we've got our operating systems here, could be Windows or iOS. McAfee and Norton are types of utility software. Now, the operating system, as I said earlier, is the foundation of the computer. Okay, but it's still not possible really to give an overall description of what it does, what it is exactly, because it does so much. Okay, so as you can see, this could be an example here of our operating system, and this is what the operating system does. So it is the human-computer interface, okay? So it's the relationship between the human and the computer that work together. So it multitasks. It has security. It's got multi-program in it. So we've got loads and loads of programs in our operating system. So if you look through your operating system and see how many programs are in there. Batch processing. Okay, so it processes lots of things at once rather than, because if it processes everything as and when, then it may be very slow. Error handling, input and output control, loading and running the software applications, management of user accounts, file utilities, processor management, memory management, real-time processing, and interrupt handling routines. So this is why it's difficult to give a description of what the operating system does overall, okay, or exactly what it is, because it does so many things. Now, so we've got a user system interface. So as we saw with the 1960s computer system, there was no user interface. It was just a mechanical computer. But now we've got so many devices and they're so user-friendly that everybody uses them. So we don't just have desktops anymore, okay? We've now got laptops. And then from laptops, we've got tablets. We've got smartphones. Then from smartphones, we've got smartwatches. So as time goes on, you know, there's always these predictions of what's going to happen. Like, for example, desktops will become obsolete and laptops will be put in place. But that's not happened. Okay, so we've got desktops and we've got laptops. Then tablets came around and they believed that laptops will become obsolete because everyone's going to use tablets, but they haven't. People have got tablets. I've got a tablet computer and I've got a laptop. And I've also got a smartphone. Okay, and the smartwatch hasn't replaced the smartphone in any way. So what has happened is, over time, we've accumulated more and more devices and we find a use simply for all of them. Okay, so, and all of these devices have all got something in common. They have an operating system and they have a user system interface. Okay, so the user interface method basically allows you to interact with the device. That is why we find some devices probably easier than others. So for example, if you was to give, say, your grandmother or any other family member that wouldn't be confident using computers, they can use a tablet. Okay, so, and for a smartwatch, it's basically you use a smartwatch because you can. Okay, so you may have a smartphone with a smartwatch because you can use them, you're competent with computers, and they become more and more friendly to use. So as you can see, you've got your desktop here with the menu here that you can see is written on your smartwatch. Your menu here is just basically icons, okay? It's so easy to use. Now, the user interfaces are essentially for us to use our everyday objects, okay? Even cash machines, for example. There's many different user interfaces, but the most commonly used are GUI, which is a graphical user interface, and a CLI, which is a command line interface, okay, and it tends to be, computer experts, people that work with computers all the time will use the command line because they find them a lot faster. Other types of user interfaces are voice activated and gesture based, okay, but I think we can agree that the graphical user interface is far more common to use. Now, programming hardware interfaces. Now, these are slightly different. So, a programmer writes software for users to run and for software to communicate with the hardware. So, in this instance, the role of the operating system would be to ensure that the hardware does what the software wants it to do. Okay, to make sure that they are communicating, because I'm sure you can agree there's nothing more frustrating than when you're pushing a button or trying to do something and it doesn't work. So, now this depends simply on the language and the tools available. So, as you know, there are several different languages, okay? So Windows uses C or C++ language. Windows and all its applications are created using C. But Android uses Java. Now, don't get Java mixed up with JavaScripting, because Java and JavaScript are two completely different languages, okay? So as you know, the JavaScript is used to embed in HTML in websites, okay? But Android uses a language called Java, and that is very different. So the tools will basically allow the program to work with the software and with the programmer and the users knowing the details of the hardware or the processor, okay? So overall, the operating system then has to provide the mechanism for execution of the program, okay? So that is what the operating system is there to do. The program is there, the operating system executes it and makes sure that all these things are working together and working efficiently. So, now, resource management. This is something else our operating system works hard with. So resource management this is the definition, a program is a process, where a program has begun execution. So in modern computer systems, a process cannot run, okay, to completion without the interruption, okay, because if you remember, the interruption will basically take place if one resource needs to go before the other. It's like a flagging system. So each process, and that's a program that's begun execution, needs to access the resources provided by the computer system. Now, the purpose of the resource management of an operating system is basically to provide the best possible efficiency to the system for it to work. And the two most important are scheduling process and a resolution of conflicts when the two processes require the same resource at the same time. Okay, so if you remember in one of the other videos, I explained that it's a bit like in school, gathering every single student in the main hall and then telling each student to go to the same classroom. Okay, so what you have is like a scheduling process. So if everybody needs to, say, do an hour of games a week, so there wouldn't be any point if we gathered all of the students up onto the green pitch, from years 7 to 13, and say, okay, your hour of games takes place on a Monday. Okay, it's a poor scheduling process, because then the PE teachers are going to be working overtime and working too hard, and the other teachers will be spending an hour doing not a lot in that hour. So what happens is that there's a scheduling process. Like the scheduling process would be, say, Year 7 have their hour of games on a Monday, period 1 and period 2. Then Year 8 have their hour of games on a Tuesday, periods 3 and 4, that kind of thing. So the scheduling process takes the time there to resolve any conflicts, because then a conflict here would be every single year group needs the sports pitch at the same time. Okay, so we have to schedule those resources, like the break time rota. So during the breaks, on a Monday, Year 7 are entitled to the green pitch. Then Tuesday, Year 8, Year 9, and then that way every single year group gets to use the same resource but at different times. Now, memory management. So there's 3 main parts. Now, memory management in a computer system obviously is very important, because if we looked at the computer system that had no memory like we did earlier, well, von Neumann, as you know, came up with the CPU architecture, and so this is how the memory works. So our computer remembers what we do and the processes. So firstly, there's protection to ensure that one program does not try to use the same locations in the memory as another program. And organisation, so they organise a scheme that is chosen to achieve the best possible user of limited memory size. For example, paging or segmentation. Then there's user optimization. So this involves the decision about which process should be used in the main memory and where it should be stored. Okay, so protection, organisation and usage optimization. Then we have our device management. So obviously computers are connected to other devices. So like I'm using my laptop, and what's connected to my laptop at the moment is my microphone. Okay, and there's other devices. So like I've got my mouse embedded and I've got my screen. So every computer has a variety of components that are organised or categorised as devices. So you've got your monitor, keyboard and printer. And these devices need to be managed to work efficiently with your system. Okay, so you need to install the appropriate driver and to control the usage by process. And then we have our file management. Okay, so if you think about how many types of files you've got saved on your computer, okay, so like for example, you may have music, videos, movies and so on. Okay, so here's the 3 main features. So file naming conventions, directories and access control mechanisms. And then we have our security management. Okay, so obviously our computer needs to be kept secure. Our files need to be kept secure. So there's several aspects of security management. So the provision for recovery of the event of data being lost. It happens, okay? It happens, files get lost, files get corrupted. Maybe you accidentally delete a file, it happens. And the prevention of intrusion in our system, and ensuring our data is kept private and not made public. And then there's error detection and recovery. Now computers do get errors, as we know, for no reason. Okay, well there's a reason but not many. Now, errors can arise from execution of programs either because they're badly written. Okay, so when you download a lot of free software, so for example there's a number of free softwares that I've used and some of them have simply crashed. Okay, so there's a free software that I use with my Year 13 IT student, and it's an animation software, and when you use the text tool it crashes. If you accidentally import the wrong file type, it crashes and then our files are lost. Then there's bugs in the code, which happens all the time. Inappropriate data, quite simply. And whenever there's an error and a reason, the operating system will interrupt the running process and try and provide a diagnostic where appropriate to recover your data. In extreme case, the operating system will shut down without loss of data. Okay? Right, so complete the questions in the homework booklet and attempt the exam type questions at the back. Thank you for watching. Subscribe, please, and like my videos. Teachers, visit my shop on Tess and follow me on Twitter. Thank you for watching.